Okay, 8.12, volume with the washer method, but now we're gonna revolve it around other axes. Okay, find the volume of the region enclosed by y equals root x and y equals x squared. No, it's if the region enclosed, got it. Okay, so I'm gonna take this thing. Okay, I want to rotate it around the y equals 2 line. Y equals 2 is right here. Okay, and so I'm going to take that and I'm going to rotate it around this thing. Okay, should we imagine it? Let's imagine it. Okay, if I go reflect up here, it's going to go like this. Okay, and then when you're rotating it, you're rotating it around. So like in the middle, it would be like a big circle minus this little circle on the inside. That's my little washer. On the ends, it looks something like this. Okay, no, that picture's not great. That's okay. Okay, but that's what we're doing. We're adding up all the little washers in that direction. Since we're going along, not the x-axis, but something parallel to the x-axis, let's do this in terms of x. Okay, in the x direction, x is 0 to x is 1. These are circles, so I'm going to do pi. And I'm going to do the bigger radius squared. Okay, the bigger radius is coming from the y equals 2 line, from 2 until the farther away one. The farther away one is the x squared. Okay, so if I want the distance from here all the way to here, I would do 2 minus x squared. That'll give me the whole distance. And then I'm going to square it. Actually, let me go like this. 2 minus x squared, and I'm going to square it. If you would rather do x squared minus 2, you could do that too, because once we square it, it turns positive, so we don't need to worry about whether we're getting a negative or a positive distance. Okay, so the order of those two isn't going to matter once we're squaring it. Okay, so that was the bigger radius. Now the smaller radius is going to be the distance from the line y equals 2 to this function that's closer to the y equals 2 line, which is the square root x. So I'm going to do 2 minus square root x. But then I'm squaring it because it's pi r squared. And I'm doing this in terms of x. Since I'm squaring it, again, you could have switched these two and it's not going to make a difference to your final result because once you square it, it turns positive. Okay, so that's my setup. I did pi times the bigger radius squared minus pi times the little radius squared. From 0 to 1, I take the integral. Okay, I'm going to go ahead and put it in the calculator. And I'm getting about 3.2463. Volume is some kind of cubic unit. Okay, let's try one more. Okay, find the volume if the region enclosed by y equals x squared plus 1 and y equals 2x plus 1, so the same region. But we're going to rotate it about the line x equals -1, so over here. My axis of revolution. Okay, again, you don't have to picture what it's going to look like, but remember, it's going to make this is going to be a circle. This is going to make an outer circle and an inner circle, and it's going to go all around like that, and it's actually going to have like a hollow tube in the middle. Okay, but let's just set it up and not worry about the picture too much. Okay, now, since I'm doing this parallel to the y-axis, I am going to do this in terms of y. Did they give me anything in terms of y? Not yet, so we're going to have to figure this out. So let me leave some space. Okay, now in terms of y, I'm going from y equals 1 until, oh, that looks clear, 1 to 5. Okay, now I want the bigger radius, starting from x equals -1, so that's going to be from here all the way to this function out here. That's the y equals x squared line. However, I need it in terms of y. So what's x squared plus 1? So x squared equals y minus 1. When I square root it, I get a plus minus. Okay, now since I'm on the right side of the y-axis, the x is technically positive, so I'll do the positive version. Yeah, that works. Okay, so that's going to be this point. And then if I want the bigger radius, I'm doing this minus this. This is x equals -1. Okay, so what is that? That is the square root of y minus 1. And then I'm subtracting -1, so I'm adding 1. and then it's a radius, so I'm squaring it. Okay, look for my smaller radius. My smaller radius is going to go from the x equals -1 to here. Okay, what is that? That's my y equals 2x plus 1 line. But I'm doing this in terms of y, so let me rearrange it. Okay, so I want to go from 1/2 y minus 1 until I get to -1. So that's going to be 1/2 y, minus 1/2, I should say. And I'm going to subtract -1, which means I'm going to plus 1 squared. And then this is in terms of y, so dy. Okay, now that I set it up, I'm going to go ahead and evaluate it using my calculator. So I got about 16.7552 cubic units.